Recording? All right. So, hello. Why is this not getting me?
Hello.
Wait, why is this not recording my voice? Hello.
That's so weird that the word doesn't respond when you say hello.
Hello. Okay, there we go. Well, I'm writing on the whiteboard, so I need to walk over there and do some stuff. So, all right. So, welcome everybody to the workshop today. We're going to be talking about coroutines and class organization. I know they sound super boring, but they're not. I swear. And they are actually super useful for a lot of different things. And it's something that isn't very easy to find online because it's not talked about a lot. But it's like the difference between a pretty good Unity programmer and a really good Unity programmer is how to use this kind of stuff to make things easier and organize things better. So first of all, coroutines. Has anybody used coroutines before? I mean, I have no. Does anybody know roughly what they are? Okay. Has anybody used threads before? Anything multi-threaded? That should do a little bit. Okay. It's kind of similar to that. So basically, Unity has a update loop. All right. And let's say we've got two objects, number 1 and number 2 in our name, and that's it, just the 1 and 2 objects. In our update loop, we run through the update of 1 and the update of 2 every frame. We go through that every single frame. We go through the code of 1, we go through the code of 2. Game runs by frame, go back to 1, go back to 2. That's how it runs. The problem is, what if you want something in 1 to say wait 5 seconds? What do you do? Now in most programs you put like sleep 5 seconds, like in Java or whatever. But the problem is if you were to put a sleep right here, the entire update loop would freeze for 5 seconds, which means your whole game would freeze for 5 seconds. That's not what you want. You want one thing to stop for 5 seconds. There's ways around it. So you could do with like if this was like a cooldown of an ability, for instance, you could do something where you're using timestamps and some math with the current time to deal with that or whatnot. But there's actually a nice, easier way to deal with that kind of stuff, which is coroutines. So first things first, make a new project, call it whatever you want. Nope, we're just working off the base stuff.
Oh, I already got a project called whatever you want.
Nice. So while this is opening up, since my computer's really slow, I want to explain one thing. So coroutines, basically what they allow you to do is they allow you to make a parallel, we say that in quotes because it's not really parallel, but they allow you to make a parallel loop that can run from a script, from something in update, that can run completely separate, that if you wanted to put a wait 5 seconds, only the coroutine would wait 5 seconds. And then after 5 seconds, it would run again. But the nice thing about coroutines is they're kind of like functions, but when you're using a function, so say this is the frame of a function. Yeah, there's a lot of rectangles. So let's say you're doing like a normal function in programming. You start right here, and say you return, so you end the program halfway through, and then you call the program, then you call the function again. Where's it going to start from? It's just a regular function. Anybody? Yeah, it's going to start back from the beginning. It's a function. It's going to go back from the beginning. A coroutine, instead, has what's called a yield command. So instead of a return, you call yield, well, a yield return. And basically what that does is you can start here, call yield return, and then when it next updates, it will continue from here, from that yield return. which can make for some really interesting stuff. If you're putting that in a loop, like this is going over and over, then you can run through, yield, and then keep going. And you can have something that goes every frame that you can control the timing of and that you can be consistent with. That's not like Update where it's, you know, all over the place. So I think that's all I need to draw on the board right now. Hopefully this marker's getting really faint. What? Oh, okay. Cool. So we've got our game. We're not going to do some really complicated game dev stuff, unfortunately, today. So first of all, make a scene. Just save what you have. I'm going to call this main, just so we have it down in case things crash. And then, so inside of here, we're going to create a 3D object. I'm just going to make a cube. You can make whatever you want. If you want to make a sphere, you can. It really doesn't matter. So we've got our cube. Cool. I'm going to name it something. Give me a name of a cube. All right, and the cube is named Blueberry. He's pretty cool. So next, I'm going to make a script so we can, you know, work with this. So I'm going to call this Coroutines. No, I'm not. I'm not going to call it don't call it Coroutines. Call it what do I have? Call it color switch. All right. And then open that up. Double click on it, open it with whatever editor you have. Doesn't matter. Yeah, sorry guys, my computer's a toaster, so it's going to take a bit, but we'll get it open eventually. No, but it does lift off occasionally. It makes the sound of an airplane, so. Alright. So, the idea of this script that we're going to write is that I want to write a script so that our game object is switching color to a random color every X amount of seconds. So if we were to do it in Update, we would, first of all, need to grab the, I believe it's the material? No, it's the renderer. It's the renderer. So we can make a renderer. I'm going to call this rend. Just normal. And then I'm going to say rend is, oh, let me zoom in, by the way. Sorry about that. I'm going to say rend is equal to get component renderer. So a renderer is what's attached to our 3D cube, and it is what is actually showing the shape visually for us. So in Update, after we've done that, no, just render. Should be just render. I'm going to say rend.material.color equals random.colorHSV. And I don't remember if that's a function or not. Yep, definitely a function. All right. So basically, all I'm doing here is I'm saying every frame of Update, change the color to some randomly generated color. So the rend stuff is just getting the renderer for that. It's not that important. So if we were to run this right now and also attach it, don't forget to attach it to your actual game object. I'm going to select Blueberry. I'm going to attach color switch. Now when I press play, it should switch colors basically every frame. So it is. That's great. Problem is it's going really, really fast. Yeah, right? We probably don't want it to be switching this quickly. This is, you know, if we let's say we wanted to give it a 1 second delay between each switch. Well, if we want to do that in Update, the problem is it can get kind of complicated. To do that, we'll have to save a timestamp of when we last switched and compare it, or we'll have to make a counter that goes up by a certain amount per frame and calculating that. And honestly, that's kind of a mess. So if we instead we can use a coroutine to sort of simplify this really easily. So to make a coroutine, it's not actually called a coroutine when you make it, but it's called an I enumerator. Don't ask me to explain the name. I don't know why it's called that. I mean, it enumerates, but it doesn't matter. That just does not matter. So it's called an I enumerator. So we're going to make it just like a function. So I'm going to call this choose color. And you give it parameters just like normal. I'm going to give it no parameters right now. Actually, yes, no, I'll leave no parameters right now. So inside of this, we can also actually at the top real quick make a public float delay for the delay between, so we can see from the editor and try different values and see how that goes. And so now what we can do is we can get rid of this and update. I'm just going to comment it out rather than delete it, so it's still there. And then in choose color, I can say while true, sorry, this is not C. While true, that instantly makes an infinite loop. Usually you're not supposed to make infinite loops. That's fine here because of the way we're going to use the yield. So now I can say rand.material.color equals random.color HSV. Just copy the same line from before if you don't want to type it out. And then finally, at the bottom, after that, we'll say yield. This is the magic statement that makes coroutines run round. Say yield, return, new, wait 4 seconds, delay, which is our public float that we determined earlier. That is the number for that. It's kind of a weird statement. But yield return, basically, anytime it reaches that, the coroutine stops and then continues, oftentimes the next frame, if it's just your yield return null, which is what you use a lot. But we're going to give it a wait for seconds. So now it will wait delay amount of seconds and then just run again. And that's it. And then the final thing we need to add is we need to actually start this coroutine, because it won't run like update constantly. You decide when they start. So we can call start coroutine like this, choose color, and then we can call it just like a function. So because that's empty, we'll put that there. And we'll use that. Does anybody have any questions about what we're doing here?
So coroutines are like built into Unity or like the C# language?
Yes. Yeah, coroutines are built in, and yeah, you don't have to define anything. It's already set up. The problem is people don't know about this a lot because, like, what would you look up to find this?
Yeah.
You have to look up coroutine. Like, you have to know what they are to look them up. It's kind of something that like someone more experienced just has to tell you about, which is my goal of like, hey guys, I've used this. You should look at this. So let's hope I don't get a ton of errors. I don't know why I would. Thank God. All right. So now let's come back to our editor, as long as there aren't any errors in there. And let's see if this works. And let's actually see if this works, because I don't have my notes up right now. So if we run it at 0 delay, it should move at it should do the exact same thing that it was before. It is. So what it's doing is it's calling wait 4 seconds 0, and it's just running every frame just like update. So it's the exact same. But actually, I can just keep it running while I'm doing this. Now I can change this value, the delay value in the object, and we can see that when I make it 1, now it will wait 1 second between each time it runs the coroutine. It reaches that yield statement, stops for 1 second, and then continues from there. So it reaches this, waits 1 second, and then continues from this line. So it gets to the end of the loop, goes back to the beginning and just calls it again, and then calls the delay again. So this is a really basic example of using a coroutine for timing. They're especially useful for loops, but you don't have to use them just for loops. If you had an ability that you wanted to go on cooldown when you press the button, wait for seconds is a really easy way of doing it, rather than trying to set up some counter or some time calculation. So now I have one more thing to show with this script. So if we go back to our code right here, I'm actually going to put float D for delay here. All right? So put this in the parameters for our coroutine. And I'm going to say wait for seconds D instead of delay. And then in the actual start coroutine line, where this is being called like a function, I'm going to put delay. So normal functions, when you're using C#, when you make a parameter of a float or a bool or whatever, and then you send it, you're actually, a lot of the time, you'll be sending a reference. What that means is, if I have an object A, and I put it into a function, and that function accepts object B as its parameter, and then I make B different, like I change B, A will also change. Because you're not sending the actual variable, you're sending the memory location that it's at.
This is special for threads, because usually you don't have other things changing things while code is working.
Yeah. Coroutines, however, are pretty unique in this, in that they don't like references. You can't even force it to call a reference. So what this means is, we're actually making a copy of delay here when we call this, not sending the memory location. So what that means is, if we go back to our program, come on.
Okay.
If we go back to our program and we call this at delay 0, it'll have the exact same activity as before, where it's going at hyperspeed. But when we change this to 1, it won't actually change. The reason it's not changing, we're changing the delay variable, but in the coroutine, it made a copy of that variable at the beginning when it was at 0, and it didn't change alongside it. Coroutines are weird like that. It's not really something that you need to know that well, but it's something that you need to watch out for, because if you're trying to make a coroutine that changes a variable and it's not doing it, that's why. There are ways around it. It's really dumb, because it doesn't like the primitive types like integer, float, bool, that kind of shit. But if you send like a custom class, it'll use the reference. So if you made a class that was just one integer, and that's all the whole class was, and you sent that, you'd basically be sending a reference of the integer. So it's kind of dumb that it works like that, but that's just kind of how it has to go. So too bad, I guess. So that's just kind of what you got to look out for with that. So let's make a second coroutine thing real quick. So if you go back to your editor, I'm going to go through one more example before we move on from coroutines. And that is, I'm going to make UI, and I'm going to make an image in our UI. So this will auto-create a canvas to show it on, and it'll create an event system. So we don't really care about those, we just care about the image. So I'm going to put the image's position at 0, 0, so it's actually on screen. Then I'm going to zoom out. And I am going to make this thing big. So actually, I think it was 500 and 300 for my, I have it at 16:9. Whatever covers the whole screen, doesn't matter. And then change the color to black. Because what we're going to do is we're going to make a fading black screen. Now, how many of you have tried to do fading screens in Unity before? Yeah, it's kind of a mess if you're using update, because you have to add or subtract things, but it can kind of make your code messy trying to keep track of it when you're doing it in update. So instead, we can use a coroutine to make that a little bit easier so we don't have to worry about as much in update. So we're going to make a new script. We're going to call it fade. Very creative, I know. Thank you. And then open that up. Is everybody following along so far? Anybody confused about something? Cool. Why is this not opening? There we go. Okay. So this is our fade. So the idea here is let's make a coroutine that every loop it's adding a little bit to the alpha of the color or subtracting it, depending on if we're fading in or out. So if we were to go about doing that, we'd probably want, first of all, a public float that we can call, I guess, fade speed. And this would be how fast we actually want our screen to be fading back and forth. So next, we can create an image. Oh, that's right. Okay. Before we do anything else, we need to add another using statement at the top. We need to add using Unity engine.ui in order to actually access the image object. So I'll slap that at the top. And then we can create an image called img, I'm going to call it. I'm going to say img equal to get component image. This should be, at this point, the whole get component thing should be pretty much second nature, because we've used that a lot in previous workshops and whatnot. And that's basically just getting the image attached to this object. So, now that we've got this, we can create our coroutine. So it's an I enumerator again. I'm going to call this, I guess, fade. Shouldn't need anything on those. Now I'm going to make two loops, well, three loops actually in here. So first things first, we want this to continuously run. I mean, you might not when you're actually, making this, but in this situation, I'm going to want this to continuously run. So I'm going to say while true, and this will be our outer loop for this. So it'll run continuously. Next, I'm going to put another while loop. I'm going to say while img.color.a is greater than 0, do something. So what that means is the color.a is the alpha value, and there's our red, green, blue, and then there's the alpha. Red, green, and blue are pretty self-explanatory. The alpha just determines how transparent an object is. If it's at 0, it'll be completely invisible. If it's at 1, it's actually a scale from 0 to 1, then it is completely opaque. Is that the right word? Opaque?
Yeah,
I think that's the right word. Yeah, okay. We're good. So right here, we've got an infinite loop, and then while it's greater than 0, do something. So afterwards, I'm going to put while.color.a is less than 1, do something else. So as the second line in each of these loops, I'm going to put yield return null. And what that does is it won't do any timing things. It will just return, it'll just stop basically. It's just calling, okay, stop for this frame once it reaches that. So whatever we put above this line will run continuously unless the object is completely invisible. and then the other one will run continuously until it is completely opaque. So here we can actually just change the color. So dot color is equal to, it'd be really, really nice if we could just change the .a value, but that's a read only because of how Unity structures its stuff. So we're actually going to need to create a new color, which shouldn't take too long. And we need to put, so now we can give it 4 values, red, green, blue, and the alpha. So we can give it the that's really not easy to read right there. img.color.r. So we're going to say keep the same red value. That's fine. img.color.g. img.color.b. So those are staying the same. And now we can say img.color.a minus fade speed, the public value that we set up there. So can anybody explain what this line is doing basically each loop? Anybody? So I don't.
Depending on what the fade speed you set it at, it's going to be reducing the alpha, making it less opaque over time.
Mm-hmm.
The greater the value of fade speed, the faster it will be.
Exactly. And then I'm actually also going to multiply this by time.delta time, which, as a reminder, time.delta time is just the time since the last frame. And the reason that's really nice is because it makes it consistent. So if your game is lagging, it'll still move at the same speed because it's relative. And it also makes it so we don't have to give it a value of 0.001. We can give it a value of like 1 because it's per second, basically is what it translates it to. So it's just much nicer to work with. And luckily, we don't need to write a super long line for the other loop. We can just copy this and paste it and simply change this minus sign to a plus sign. So that way, now that we're moving towards being opaque, we're just adding to that alpha value. Does anybody need to see this longer? Does anybody have any questions?
For whatever reason, my fade is all that in squiggly.
Your fade?
enumerator fade.
Did you capitalize it the same as your class?
Oh.
Yeah. That's why I made my coroutine lowercase.
I just had a quick question about can you scroll over?
Yes.
Just like your order of operations. So are you taking delta time just times the fade speed?
Yes, just times the fade speed. We wouldn't want to set the alpha to anything that's multiplied by anything. We're just adding something. We're adding that fade speed, but then multiplying it by time.delta time makes it much easier to work with, and it makes it more consistent.
I'm usually not that good with order of operations, but I was pretty sure the multiplication happened.
Yeah, it does. If I'm doing it with better coding practices to make it more clear to whoever's reading this, I would give this an extra parentheses to make it clear that that's how that's going.
Yeah.
So that is a good point. That does make it more obvious. What?
Did I see some data component stuff because I'm having an error somewhere?
Yes. Did you add using UnityEngine.ui to the top?
Yes.
Okay. That's something that I always forget about, is adding stuff like that, because then it's issues. So basically to sum up coroutines, honestly, they're basically just taking a part of the update and making it much more customizable with timing, with objects, with all sorts of
Some of
stuff.
my errors were just like little things like I forgot to compare parentheses at the end of the game.
But that's the stuff that breaks projects, man. It's not the big errors. It's the oops, somebody forgot a double equals in the if statement. So yeah, we lost 2 weeks of work in my 309 project because of that. So now that we've got this, I need to make sure mine doesn't have errors actually.
So like if we were to run that right now, it would fade out and fade in.
Yes, it would just fade back and forth forever. Just, I mean, this wouldn't be very practical in your game, but for the sake of this.
Do we not need the infinite loop? Like if we were to just
If you just wanted to fade to invisible, for instance, you would not have the infinite loop. You just have to while that. Because that's true. I actually haven't shown when a coroutine ends. Coroutine ends basically when it just reaches the end of it.
Yeah.
So if we didn't have this while true statement, it would reach the end of those loops, and then it would just stop, and that's when it would end.
Okay.
And then if you wanted to start it again, you would call start coroutine again. Speaking of which, thank you. We do need to start this. So back in start, you need to put start coroutine, fade, just like that. There's another version of start coroutine that none of you should ever use. I don't know why anybody uses it. There's a version of start coroutine that you can call the coroutine by string. So like you would call it like start coroutine, and then you'd put like fade, and then whatever you put in the extra stuff. So it'd be like null. Don't use this. It's dumb. I don't know why it's even an option. I don't know why you would want to use it. I guess if you were specifying like by user input, like what string to use, I guess it has its uses.
But then,
but
like, how would the user know what methods the code is using?
it would have to be something just used by the dev and like for customizing. Don't use it. Don't use it. It's there. Don't use it. It's just dumb. Yeah, you can use the string to ID the coroutine. It's dumb. Don't.
Well, that's modularity.
It's useful, but you probably will never use it. Or if you are, then there's other issues that are in you got to deal with other stuff anyways. So for the most part, just call it like a function. It's much easier to deal with. Much less errors with capitalization and whatnot. So now that we have this, I'm going to click on the image and attach the fade object or the fade script. I'm going to give this fade speed, I don't know, 1. I don't actually know how fast that's going to be. We'll see. Well, since it's since it's multiplied by time.delta time, it might be at a more reasonable speed. I'm not sure. So, but yeah, if it was not multiplied by that, 1 would just go from 1 to 0, 1 to 0, 1 to 0, 1 to 0. So,
Oh, yeah.
now we can see that while our cube is going absolutely crazy in there, that our screen is now fading smoothly back and forth. And this no longer clutters our update. This is kind of something, that would be silly to be putting a ton of lines in our update for, and we don't even have an update. Our update's blank. This is just something that all we would need to do, and even if you didn't put it in start, even if it wasn't infinite, whenever you wanted to call fade to 0 or whatever, you could just call start coroutine this, and then it would just start doing it. And you can customize it a lot. So you can put like yield return, new wait for seconds, and you can have it so it delays at an incremental time or however you want to set it up.
You could also put weights in between the while loops to cause it to stay open and close for something like that.
That's true. You could also do that if you wanted to customize that.
Can you call methods out of a thread?
Out of a coroutine, you mean?
Exactly. Because
yes, you can. Basically, the benefit of a coroutine over a function is the fact that a coroutine can stop and then continue, whereas a function has to go completely in one go. So if you called it in a coroutine and you called that function, it would just go through the entire function and then return back, and that would be it. So it would.
Method that calls the coroutine can carry on.
Yeah, it is treated just like if it was in an update loop or something like that.
This doesn't really matter, but do you think you could get it to line up to where every time this the black fades out, that it's like a different color, so it's like red, black, yellow.
Probably. Hang on. All right. Let's see. What's the? So this should be 1 per second switching. So if we had blueberry to 2.
Yeah, that should work.
Ooh. Oh, it switches like just before. No, it's pretty good. There you go. So coroutines basically just open up a lot of different doors of things you can do, and they are really useful. But it's just the only issue is that there's just not as much documentation on them, and there's just not as much talk about them. So it's hard to even know that they exist. I found out they existed because I saw Ryan use one while standing over his shoulder. I was like, what is that? And then I looked it up and I figured it out, and I was like, this is super useful. Why don't people know about this? Yeah, exactly. It's like a oral tradition. It's like it goes from mouth to mouth, not across the web or anything. It's crazy. So let me see what else I had for this. This was the fade. Do you guys want to move on, or do you want to see one example of like a cooldown for like movement of the, if we wanted to move the cube? What? Shut up. Shut up. This one makes sense. All right. Shut up. I don't want to hear it. If you guys don't know, no, never mind. I'm not bringing that up. Oh my god.
In this
low blow, man. Low blow.
Project, you can make a cooldown on movement if you want.
Oh boy. All right. So, do you guys have a preference either way? Because I can move on to class organization, which is also really useful because it's something that I'm sure you guys have wanted to use in projects before. All right. Let's move on then. So now we're gonna make a new scene. So create scene. It's just gonna be a blank one. Call this. Oh, give me a name for a scene.
What?
Give me a name.
Strawberry.
Strawberry. Okay. All right. We're doing fruit today, I guess.
Berries.
Yeah, that's. I guess those aren't fruit, but whatever.
I have like so much trouble with that.
Yeah.
What's a tomato? Thing.
It's some horror. It's some thing nobody knows.
Organic matter.
So what we're gonna do is this is gonna seem really boring because we won't actually be able to see any results in our like 3D space or whatever. But this is how to make your thing. This is how to make your scripts look beautiful, and it's something that again nobody talks about, but it's super nice. I'm sure you guys have all wanted to do this at some point if you've worked with Unity before, and that is what? Oh my god. You know what? Actually, the color just literally does not matter, so it's fine. I'm just going to center this. Move to it. So, I'm sure you guys have wanted to do this before. When you make a script, how many of you have wanted to be able to customize the inspector so you could make like drop downs and whatnot to organize things before? So if you had movement values, you could put those inside of a drop down so it wasn't just a mess of 50 different variables in a row. Anybody wanted to use that before? You have? It's pretty cool. There's no like option with Unity to customize in the inspector like in a way that makes a lot of sense. So the way that you can do it is I'm going to make another script. We'll call this. All right. This is important for this workshop. So for this example, the example I came up with is the most boring thing that I could ever think of. So please, somebody give me a better example that'll work. My idea was a library of things nested in other things with values at the bottom level, like title and like author and whatnot. Does anybody have a more interesting example of something similar to that?
The library of Babylon. What's the name of that?
Well, not like a specific library, but I mean like a different nested, just like a different nested object of some kind.
Oh, I see. Actual Russian nesting dolls.
Okay.
Matryoshka dolls.
Okay, that doesn't work as well because there's only like one in one. Like a library has like a bunch of books on a shelf, a bunch of shelves on a bookcase. Maybe.
So you're talking about something that contains
Bookshelf.
Yeah, just spilled water all over myself.
Okay, what if you have like a book and you hollow out the book, and inside the hollowed out book you have another book, and then inside of that hollowed out book you have like another.
But there would have to be multiple. There'd have to be multiple. All right, I'm just gonna go ahead with the library. All right.
In one box, and
each one of those
All
4
right.
boxes have another 5 boxes in them.
I have all right. I have a second more interesting example, but it's not as clear as what's going on. So we're just gonna do the library first because too bad. This is getting. I don't know how to explain some of these things. That's gonna be way too confusing. Saying box of box of box of box. At least these are named differently. So we're just gonna do the library.
Wait, okay. You can do the universe. Like, the universe has galaxy clusters, then galaxies, then solar systems.
Yeah.
All right. No, we're doing the universe now. It's gonna be called universe. I'm just gonna completely delete this. I'm sold. That works. That works.
Then it's got bacteria, then it's got subspace, then it's got the universe inside of that, then it's got galaxies on it. Have you ever seen someone play everything?
Oh my
Yes.
God. The deer like rotating.
I want to play as a fence. Oh boy.
I want to be a blade of grass and then a mountain.
Wait, but the fences are so fun to play as.
Universe.
Just put, like, more fences, and it's like playing Snake.
All right. So we're gonna make a script called universe, or if you named it library, who cares? It can be called library. So first things first. We want to create an object of type the universe. All right. Problem is that's not I don't think that's a Unity default type. Last time I checked, I don't think the universe is a default Unity object type. Anybody, any confirmation? I don't think so. So if we wanted to make a universe type, well, okay. Let's say this. Let's say we did this without using any special classes or organization or whatnot, and we just wanted to make our variables. All right. So let's say we have a let's say we wanted to name everything, so we could do a string universe, string array, or actually this would be public string, my bad. Public string array of galaxies. So we've got our universe, and then we've got however many galaxies. So let's say this is a really small universe, and we've got 5 galaxies. All right. So then let's say public string star system or solar systems. All right. Let's say each of those galaxies had 10 solar systems. I mean, this is a really small galaxy, or this is a really small universe. The problem is, right now, as we have it, if we wanted to do that, just that, only the solar system, no planets, no other universes somehow inside, like Nate was talking about, none of that, if we just wanted that much. Problem is, this becomes horrifically ugly to look at. So all we've added is those 3 objects. But when we do this, we have the universe. Let's call it Gerard. I don't know why it's called Gerard. Galaxies, so we've got 5 of them. And I'm not even going to bother naming these because it's not going to matter. Problem is, if I wanted 10 for each of these, we're adding 50. 50 objects. Now, tell me, which of these is in galaxy 4? Well, I mean, I guess you'd have to, let's, 39 to 30 would be in galaxy 4. Cool. This is easy to navigate. What happens when we add planets? What if each solar system has 5 planets? Well, now you're up to 250 planets, and then you're counting out each one. It becomes a mess, like, instantly, and it just becomes awful to work with. So, an easy way to fix that is to create custom classes, just for the sake of organization. So, I'm guessing a lot of you have used Java to some extent before. You've used classes. What was the example they used for you guys? Was it basketball or balloon? Usually it's basketball or balloon.
Basketball.
Yeah, basketball. They make a class, and then it's got, like, inflate, it's got pop. Thing is, classes like that in Unity are pointless, because that's what objects are in Unity. Unity is super object-oriented, so if you wanted to make a basketball class, you just make a basketball object with the script attached to it of having pop and inflate and whatnot. So you wouldn't actually create a class for that, you just have an object. So it's set up differently. But you can use classes to organize things super well as some other stuff that doesn't matter right now. So here's what we can do. So first of all, we're going to need to add one thing of using. I put it at the top because it makes sense once you write it. Using system. Just system. Just plain old system. And that's gonna let us use a certain field that's really, really useful. So, everybody got using system? Now we're going to go below this. This is crazy, I know. I don't think we've ever done this in a workshop. We're going to leave the main class. We're going into uncharted territory. Nobody knows what's out here. So, we're going to make a public class, and I'm going to call this, oh no, I can't call it universe. That's the name of this whole thing, which is probably a bad idea to name it like that, but whatever. I'm going to call this universe. Public class universe. So up here, just like here, we've got public class. I'm not going to add mono behavior because we don't need that. Mono behavior is used to specify that we have update in there, that we have start, that we have all the default stuff. We don't care about that.
Okay, that is the same name as the public string.
Just call it like universe class.
Yeah, that's actually fine. And that's because the string is actually inside of this class, and we're working outside of that class.
Oh.
Plus, we'll change the name of this in a bit. So we're going to say public class universe, curly braces. And then we're actually going to add one thing above public class universe, directly above, one line above, and this is what we needed system for, and that is the serializable field. No semicolon, just in square brackets. The reason we put the serializable field is basically saying this is not the main class, but we can still change variables from inside the inspector in the Unity editor. So we need to add this before it so it knows that you can do that. So we've got our universe class. Let's make a few more. So inside each universe is, what was it, galaxy. So we're going to make a galaxy class. Oh, also with the serializable. All of these need to have the serializable. I'm going to make a public class solar system, I believe we had. And this won't take forever, don't worry. Even though there's a lot of these, it's not going to be awful, hopefully. And we'll make, say, planet. Any more? Did anybody have
Life form.
the life form? You know what? You know, I'm actually just going to stop at planet because it's probably going to get too complicated if we keep going now that I think about it. So we've got all of these classes that frankly don't do anything, but we can give them values to keep track of stuff. So first of all, planet. What values can we attach to planet? First of all, we should probably put a string name, the name of the planet. Float, I don't know, density. I don't
Diameter, size.
yeah, you know, stuff like that. I don't know, you know.
Inhabitable or not?
Yeah. Let's put a boolean. Let's put a boolean. That's a good one. Inhabitable. Is that spelled right? I think that's spelled right. So we've got, you know, 4 variables or whatever attached to this. You can put as many as you want. If we were doing the book example, it'd be like a title, author, is it available, that kind of junk. So we've got this stuff attached to planet. That's great. Now, what would a solar system have? Well, a solar system would probably have, at the very least, a name. And it might not have anything else. It might just be a name. But a solar system has public planet, or, You guys know what lists are in Unity, as opposed to arrays? You ever used array lists? Any of that junk? Okay, we're just going to use arrays, that's fine. So I'm going to make a public planet array called, I don't know, planets. That much doesn't really matter. So now what we've done is each solar system now has an array of planets inside of it. And each of those planets has name, density, diameter, and whether it's inhabitable. So now in the galaxy, when we move up further, we can put a string name. It's a really good idea to put a string first, and you'll see why in a bit for these. So then we'll put public solar system array. Solar systems has an S, so it's different basically. And we're going to do that going up to universe. So now we've got string name of the entire universe. And we're going to put public galaxy array, galaxies, and there we go. So now we've got nested objects that hold arrays of each other. And now in the main class up here, does anybody need more time to look at this?
Yeah.
Does everybody understand what we're doing here and how this is set up? Because this comes so in handy when you're working on scripts that have a lot of variables. When you're working with really complex stuff, because you can organize things in extremely easy ways. Good?
Yeah.
Okay. So then up here, we're going to delete this. We don't need these lines anymore. We don't need strings. And so what we can put is we can put public universe, call it whatever, you know. I already called it Gerard. I like that name. Actually, you know what? We have to name it somewhere else, don't we? Just gonna call it U. Public universe U. So let's make sure we're doing all right.
I'm sorry, can we call it Zappa?
We'll call it that in the editor for sure, definitely. All right, so now, oh, you get one last look at all those. Whew, that's looking god awful. So instead of having a bunch of different arrays for each type of object, because you know you might have a ton, instead we've got this nice little U. That's it. That little U has a drop down. It's got galaxies. Cool. So how many galaxies do we have? Let's say 11. We'll give it a high number, sure. Now we've got these. Now this can get kind of complicated. You got elements 0 through 10. That's kind of obnoxious. But I'm an idiot. Hang on. Go back to the code. Put public before all these strings. I was wondering why that wasn't showing up. Whoopsies. And public before all of these. Wow, that was just embarrassing. Just put public before literally all of the variables. Sorry about that. What's up? You guys good?
So some of the string float, and move.
Yeah. Public before all of it. That was my bad. I kind of forgot about that. So now you should see this change a little bit. Because we should get the actual name values. There we go. So, now that this is updated, we can name our universe Zappo, I think it was. That's cool. That's good.
Zappa.
Zappo. Nice. So now if we want to name this galaxy, this is a nice thing about putting a string in a class, special class for an array in Unity. If we want to name it something, what's the name for this galaxy?
Frank.
Frank. If you notice, when I type the first letter, it puts whatever the first string is. If you have a string at the top, it replaces the drop-down with that. So now instead of element 0, we now have Frank. So if we named all 11 of these, we would have distinct names for all of those that you can use to ID them. So even if you're not using the string necessarily, it's usually good practice to put a string so you can ID what is actually the name of each of these. So now we've got a galaxy named Frank, and it's got solar systems in it. How many solar systems? Only 3. All right. It's a really small galaxy. So we got 3 solar systems, and each of these work the exact same. So this solar system's named Kepler 1, okay. Kepler 1.
Yeah, you capitalize the one. That's master.
So, now we've got a solar system named this, and we've got planets inside. How many planets? You're right, 400. Yeah, it's big and it's ugly. Okay, that's actually making it lag a little bit. I'm going to put it down a little bit. 40 is good. There we go, okay. So, our first planet, now we have all of these objects. Now, it's not very easy to see right here because this isn't stretched out very well because there's so many objects inside of each other. But, now we can name these. So this can be
Cosmic debris.
Cosmic debris. That's a nice planet. Cosmic debris. It's got a density of 5. I don't know what these values are. It's got a diameter of 2. 2 what? You decide. And sure, it's inhabitable. And we can name each of these and ID them from here, going through the entire list. And when we're done with the planets in Kepler 1, we can put that down and start working in... Wait, this is a galaxy. In another galaxy, whatever it is. And the nice thing is, Unity also does something really, really helpful for us, in that it actually saves your drop-down position. Which is, I don't know why they do it, but it's really nice. So, I guess that's why they do it. So if we wanted to put away universe, so it's completely gone, and then we wanted to open up universe and change something, it actually keeps track of all of the drop-downs you had down. So it's all the way back at cosmic debris, it saves that. And if we did half of it where we wanted to work on a different galaxy, and then we wanted to go back to where we were, it would still keep that stuff open. Which is kind of a blessing and a curse, because if you're trying to just close everything, you actually have to close everything. But it's really nice for keeping track of what you've put down and what you've done. So would you guys agree that this is a way better organization method than having 250 variables in a row and trying to remember which ones go to which? Is that fair to assume that this is way better? Yeah, this is super helpful for a lot of stuff. Now, in terms of game development, this doesn't really seem like very much right now. I mean, we're making a universe. It doesn't really do anything. So I have another example of one that I actually used for a game that I was doing. So, and you guys, I guess, don't need to write this with me if you don't want to, since this is basically just the same thing but with a different example. I'm going to call this, that's good. So what I did this for was I used this for a tower defense game I was working on. And what I realized would be a problem was that it was really difficult to save waves of enemies into a single script and customize that from level to level without having horrific organization, like really, really bad organization. So what I did was, I'm kind of improvising this, so I might go back on a few things. First of all, I need serializable public class. Copy that for later. I had, I believe it was wave. For waves of enemies. And then I had, no, it wasn't wave. All right. I swear I'll get this. I had round for every round of what was going on. And then each round had a certain amount of waves. And then each wave had a certain amount of enemies that came through it. And these enemies had, public string name, public int health, I don't know, something like that. And then for each of these waves, I had public string name. Although I don't think when I did it, I actually used names, since you don't really need to specify what wave 1 and wave 2 are. It's just element 1 or 0 or whatever. So, and then I had, of course, public enemy array, enemies, and then public string string name public wave waves.
So when you go to set up each wave, you have to individually put in each number for each enemy, wave, and such.
Yes.
So you can't copy and paste these types of elements.
Yeah, you can't copy entire objects at a time. But the reason it was useful is because sometimes you want 3 enemies in a wave, or 3 enemies in a wave. Sometimes you want 8 enemies in a wave. Sometimes you want different types. And when I did it, I actually had a public game object enemy or whatever, and I was putting in, that was for instantiation. That was for prefabs.
Okay.
However it was set up. It wasn't set up the best. I'll give you that much. And then I had public rounds. I think I have this set up correctly. Maybe. Gotta give it time. So I had a certain amount of rounds. My, level 1, the scene had 5 rounds. Round 1 had 3 waves. Each of those was, you don't need to rename these. You could just leave as element. That doesn't really matter. But then I had a certain amount of enemies, and wave 1 had 10 enemies. This one had 10 health. Maybe this one had 10 health. And you could, write a script to standardize things if you wanted to make it faster so you didn't have to enter every single entry. But the reason I used this was because I could use the same script for the whole level, and I could keep track of which wave was which, and which round and whatnot. But it made it so much easier to customize because I didn't have to keep track of every single variable. And I could just put in, whatever I wanted. And I had a float for the time between each wave, because there's a time between when the waves go for faster waves or slower waves, movement speeds, all that kind of stuff. And it made it way, way easier to organize. And I encourage you that if you have a lot of objects or a lot of variables in a script that are attached to different objects, use this kind of structure, because it makes it so much easier to tell what's actually going on. Because this is sort of the life hack way of, I hate that word, this is the sort of that way of making the inspector customizable with drop downs and customizing numbers and stuff. The last thing I wanted to show you was how you actually access variables in here, because you obviously have to use the enemy thing in there. So for instance, I can say rounds dot waves. Oh, not waves. What is this? Oh, that's right. Since this is an array, I can say the first round dot waves, first wave dot enemies, and the first enemy. And then I can do dot to get whatever type is in here, so I could get the health. That would be returning the health of that enemy. And you can use them for some really helpful things. Like, for instance, if I did a for each loop, and I said enemy E in round 0 dot wave 0 dot enemies, and what that would do is it would run one loop for every single enemy in that wave, and E, whatever E is pointing to, would be that enemy for that turn. So then I could say E dot health equals 0, and this might be for if they reach the end. If you don't succeed, they would die at the end, but they do damage to whatever you're protecting. It's a tower defense. I don't know. There's a lot of different things. So this right here, this loop could be used to kill enemies that reach the end. That it runs through the whole wave and ends them. So you can still access them fairly easily, although it is nested, so it's kind of weird. but you can still use them in ways that are really, really useful. I'm just gonna get rid of that. I'll do this. Does anybody have any questions about coroutines? I know those seem like they happened like a year ago. It's been a long presentation. Or any questions about class organization? Who's bored out of the mind? Yeah.
Actually, only been going for now.
Hmm?
It's only been an hour and 5 minutes.
Did anybody want to see any other examples of things at all? Any questions? Yes. When I was developing that, I actually used classes to separate like the movement values, the graphics changes, and the like when you shot the laser. Like I actually separated those into classes. So for all of the public movement values, I had a drop down for if I didn't want to deal with those at the time to organize it better. Which, if you're doing class organization for functional stuff, it's not as good of an idea. It can help you organize the code, but then there becomes issues of what do you actually have access to. For instance, if you have two classes that are, like you have the main class, and then you have two classes off of that, this class cannot access values from this class because it can't go upwards. It can only go down. It's
Unless
weird.
It has a parent only.
You would have to set up some connection. It's goofy. I wouldn't do too much functional stuff, but it's really useful for organizing values for public stuff, for like customizing levels and whatnot.
Now I remember where I was using this. In CleanStream, I had rhombuses as the edges of everything, as well as hexagons for the edges. And so I had to connect up everything to everything else. So there's rhombus and hexagons. And rhombuses had connection to 2 hexagons, and each hexagon had 6 rhombuses. It was
Sounds horrifying.
a number of hours. Yeah. And then each rhombus had like a stream on top of it or a line. And then those would be instantiated when you drew over them, or they'd have villages. They could have 2 different villages.
Oh my god. You poor soul. Oh, you got it to work, so.
I mean, it did turn into stuff like this, Jacob.
Ouch. But yeah, hopefully you guys use this in the future. The class thing is pretty useful for some things, but coroutines are certainly useful for all sorts of different things. Basically, if you're doing anything time related, in terms of any time you want to wait or you want to do something over time, consider using a coroutine instead of doing update. It's really easy to do. And the nice thing about coroutines as well, to the people who've used threads at all, you know that there's issues when things are not synchronous or asynchronous or whatever, where data is being changed and stuff isn't. Unity, there's no such thing as asynchronous with coroutines, because everything runs linearly. Coroutines just run at a different time, but sort of alongside of it. You won't have to worry about variables being different throughout. So it's really nice for that. Makes it so you don't have to worry about a lot. All right, well, if that's it, then that's it for the workshop. Thanks for checking it out. I'm going to stop this then.